Hello all, this is Mr. G, and this is our warm-up for today's lesson. So pause the video right here, give this problem a shot, come back when you think you have an answer. We're going over in 3, 2, 1, let's go. So the directions say solve the equation for C. So basically, we're not going to be able to find a numerical answer. We're not going to get a number answer here. We're not going to end up with like C equals 7 because we've got not C but B's here as well. We have extra variables. So the best we can do is just get C all isolated, all alone on one side of the equation. To do that, let's see, we've got a 2C on the left side of the equation and a BC on the right side of the equation, on the right side of the equal sign. What I'm going to do first is get everything with a C on one side and everything without a C on the other. So tell you what, let's subtract BC. Let's use our inverse operations to move that to the other side of the equation. And let's move the 5 as well. That 5 does not have a C, so I'm going to move it just to the other side of the equation, just to get it out of the way. That'll cancel out there, and the BC's will cancel out. So we're left with 2C minus BC equals B minus 5. Now, the trouble is we've got a C in both of these terms. We've got a C with the 2C and a C in the negative BC. And that can cause some trouble when we're trying to get C by itself, because I don't want, like, how do I want to say this? Basically, we want just one C equals something on the other side, and we don't want a C on that other side. So it's not like I can just move the BC over and divide by 2 and be done with it, because this C will be on the right side then. So here's what I'm going to do. I like to use a GCF at this point, or in this particular type of problem. Hopefully you remember this from Algebra 1. A GCF, when we factor a GCF, a greatest common factor, it's the exact opposite of the distributive property. When we distribute, we multiply into a set of parentheses. When we divide out a GCF, or when we factor a GCF, we're really dividing something out of the parentheses, sort of undistributing, you can think of it. So what we're going to do here is we're going to look right there and see what do those two terms have in common. Well, hopefully you're seeing they both have the variable C. That means we're going to divide that C, not from both sides of the equation, we're going to divide it out in front. So we're undistributing, so we're going to end up with a C in front of something in parentheses. We're dividing it out and creating parentheses. So those C's cancel out right there. So that just becomes 2 minus those C's cancel out as well, and we end up with B. So we have 2 times C times 2 minus B equals B minus 5. Now this might not look better, but what's better about this is there's only one C. There's only one of the variable that we're trying to get by itself. So we're actually one step away from being done. And the key is that multiplication. It's C times everything in that parentheses. Well, okay, so all we have to do to get C by itself then is to cancel out the multiplication. And we cancel out multiplication with division. So I'm going to divide both sides by 2 minus B. Well, okay, so the 2 minus B and the 2 minus B cancels out. And then we're left with C equals B minus 5 over 2 minus B. And we're done. I mean, it's kind of an ugly answer, but it's an answer. Now, this is not the only answer you could have gotten, depending on, let me jump back up. Depending on whether you move the BC or the 2C first, like if we had, instead of subtracting BC, if we subtracted 2C from both sides, then your answer would look slightly different. It would look C equals 5 minus B divided by B minus 2. So you get sort of the same thing, but in an opposite order. Now, either of these answers are completely correct. You do not need both. You only need one of these answers. But in case someone had this answer written down, I didn't want them to see the first round. They go, no, I'm wrong. Both of these are completely correct. Let's take a look at our objective. Today we're doing Chapter 3, Section 3, and after today we should be able to graph absolute value functions. So we're still in the same section we were dealing with yesterday, but we're sort of taking a little break, a little hiatus from the systems, because we need to make sure, before we get to our next type of system, we have to make sure we're really good at graphing absolute value functions. This is something you may have seen in Algebra 1, you may not have, so let's do a little review. Absolute value function review. This right here, f of x equals a times the absolute value of x minus h plus k, is sort of like our, it's almost like slope-intercept form, y equals mx plus b. Y equals mx plus b tells us how to graph a linear function. This form, which I'm going to call vertex form, tells us how to graph an absolute value function. So the reason I'm going to call it vertex form is because it gives us the vertex. Now remember, hopefully you remember this, an absolute value function always makes a v. And the vertex is the point right there. Not the origin necessarily, but the point of the v. That's what we call the vertex. Very similar to the vertex of a parabola. Hopefully you remember that as well from Algebra 1. Now the vertex is always hk. Just like the slope is always m in a linear equation, or the y-intercept is always b, the vertex is always hk, so h and k. Now you have to be a little careful with your h value, because if we look at vertex form, we notice that, it's a negative h, it's x minus h. Now what that essentially means is anytime we take our number out, we take our h value out of the absolute value function, we have to change the sign. So if it's negative, it comes out as positive. So for example, if this had been a negative 2, like x minus 2, then the h value would have been positive 2. If it had been the absolute value of x plus 8, then we would change the sign and the h value is actually negative 8. All right, so you've got to remember that. Whenever you're finding your h value, the x coordinate of the vertex, change the sign. Now, don't think that has anything to do with the absolute values, all right? We're going to see other functions this year where it's x minus h and we have to change the sign. Don't think, a negative always becomes positive in absolute value. It's got nothing to do with that. Well, I mean, really, how do I want to say this? We just change the sign because it's right there with x. It's inside the most important part of the function. We can think of it that way. All right, now our a value, whatever's in front of the absolute value, is sort of like slope. I've got slope in parentheses, or not parentheses, in quotations there, because it's not exactly slope. Well, I guess it's like slope half of the time. So if we start at our vertex and go to the right, then it's going to end up looking a lot like slope. We're going to go up and to the right, up and to the right, no problem. But on the other side, moving this direction, normally, if this was a line, we would switch it and go down and to the left, down and to the left. But since we want this to make a V, we sort of reverse it and we go up and then to the left, up and then to the left. So that's why I've got it slope in quotes there. It's not exactly the same thing as slope, but we can sort of think of it like slope if that helps us graph it. Now, the next thing I want to do before we jump to our next slide is talk about one thing here that really makes this vertex form. Because in slope-intercept form, not every equation is automatically in y equals mx plus b form. We have to get y by itself. We have to manipulate it. What we need to look for here is the number in front of x. The number right in front of x. Not the a value, the number in front of x. That number in front of x must be a 1. There must be an invisible 1 in front of our x. Otherwise, it's not in vertex form. So if you see anything besides a 1 in front of that x, that means you've got to do some manipulating to create vertex form. All right, so let's jump to our next slide. Now there's one property of absolute values that we need to talk about. This is not the only property of absolute values, but this is something we're going to need in today's lesson. So it says the absolute value of a times b equals the absolute value of a times the absolute value of b when a and b are real numbers. Now, this is how a lot of your mathematical rules are going to start looking the higher you go up in math. It's going to be mostly variables. So this is something you want to get good at reading and understanding. Because once you get to pre-calc and definitely like calculus or statistics, it's going to be mostly variables in your rules. So what this is saying is, okay, if we've got two real numbers inside an absolute value being multiplied, that means we can rewrite it as the absolute value of one times the absolute value of the other. It's almost like we're splitting them up. Basically that's what we're doing. We're splitting them up into two separate absolute values and then multiplying. Now, we can only do this with multiplication or division. We cannot do this with addition or subtraction. If you try and use this rule with addition or subtraction, you're going to be wrong. Right? Now, right here, I've got an example of how this would actually look with some numbers in case that will help. So we've got the absolute value of negative 2 times 7. Now, we could just simplify. We could just say, okay, negative 2 times 7, that's negative 14. And then the absolute value of negative 14, well, that's 14. But we can also get to that same answer using our property. So up here we said, okay, the absolute value of negative 2 times 7 That's the same thing as the absolute value of -2 times the absolute value of -7. We took those two numbers that we were multiplying inside the absolute value and we split it up into the product of two different absolute values. And then obviously we just get +2 times 7, which gives us 14. The same answer done two different ways. Now we're going to need that property later, so hopefully that made sense. Here's example 1. It says graph the function f of x equals 1/2 x minus 2 minus 2. Oh, 1/2 times the absolute value of x minus 2. I think I forgot to say that, and then a minus 2 at the end. Now let me slide this down just a little bit because I want to write our vertex form under this. So it's f of x or y equals, it doesn't make a difference, a times the absolute value of x minus h plus k. Now we got to think about this. The first thing we have to make sure is that this is actually in vertex form. And if you remember a couple slides ago, I said for an absolute value function to be in vertex form, we must see a 1 in front of the x. Not outside, like this is a 1/2, but that's fine. I'm talking about the invisible 1 right in front of the x, and we do see that. There's nothing in front of that x, so that means there's an invisible 1. So this function is ready to be graphed. All we have to do is find our h and k, find our vertex, and then find our a value. So the vertex will be, let's see, we see a -2, but that's in the place of h, so we have to change the sign. We see a -2, so h is actually +2. K is a -2. We don't have to change the sign of k. We only change the sign of h. Or we only change the sign of what looks like h is. Let me say that a different way. We only change the sign when we're finding h. That's a better way to say it. We only change the sign when we're finding h. So then we go +2, -2, so right 2 and down 2. That's our vertex. Now to finish graphing, we need our a value, our quote-unquote slope, which is a 1/2. So that means on the right, going this direction, we just do it like normal slope. We're going to go up 1 over 2. So up 1, right 2, let me get that out of there. Up 1, right 2, up 1, right 2, up 1, right 2, and we keep on going as many times as we can. But going to the left of the vertex on the other side, we do not switch the slope like we normally would for a line. We still, like we don't go down 1, we still go up 1, but now we go left 2 to create our v. Remember, an absolute value function always makes a v. So up 1, left 2, up 1, left 2, keep on going as many times as we can. There we go. And there's our absolute value graph. All right. Let's take a look at example 2. So example 2, it says graph the equation y equals negative the absolute value of 4x minus 12 plus 7. Again, first thing we have to figure out is this in vertex form? Hopefully you're saying no, it's not in vertex form because we see a number besides 1 in front of x. That must be an invisible 1, otherwise we are not in vertex form. So I'm going to have to drag this graph down a little bit because we've got a little manipulating to do. Remember, just like in a linear function, if y isn't by itself, that doesn't mean we can use y equals mx plus b. It means we've got a little work to do. We have to manipulate the equation. Same thing here. We've got to manipulate this equation so that we end up with just a 1 in front of the x. So I'm going to rewrite this negative absolute value for x minus 12 plus 7. All right. So basically, how do we get rid of this 4? We get rid of this 4 by using a GCF. I didn't use a GCF in the warm-up for no reason. Like I specifically chose that warm-up so we would have that in our minds. What we're going to do is we're going to divide out in front and create parentheses. Remember, we're going to do the opposite of distributing. So the y equals comes down, the minus, the absolute value, all that comes down. But we're going to divide these two by 4. We're going to divide a 4 out in front of these parentheses we're going to create. Now, here's a little trick, ladies and gentlemen. Actually, no, I'm going to wait for that. I'm going to wait on that. Spoiler alert. So 4x divided by 4 becomes x, minus 12 divided by 4 becomes 3, and the plus 7 comes down. Now let's get back to that trick I wanted to talk about. The number you're going to divide by, it doesn't, I don't want to say this. That 12 has no bearing, has no effect on what we divide by. To create vertex form, we must always divide by that 4. Or not the 4, but whatever number that is. Whatever number is in front of x, that's what we have to divide by, because that's the only way we're going to get an invisible 1 in front of the x. Something divided by itself. So this 12, I mean, yeah, it divided nicely and we got a 3, But if that 12 had been like a 5, we still have to divide by 4. If that 12 had been a 17, we still have to divide by 4. Because that's the only thing that's going to create that invisible 1 in front of x. Now, we're ready to use our absolute value property. Because basically, this is still not vertex form. Okay, we've got the invisible 1 there. But I mean, inside the absolute value, it's supposed to just be x minus h. Here we've got 4 times parentheses. That's no good. But we can get around this. So I'm going to put y equals negative. Now, here's what I'm going to do. We've got 4 times something inside the absolute values. So 4 times something inside absolute values. Well, we can use our absolute value our absolute value property. There we go. All we have to do is say, okay, I'm going to rewrite this as the absolute value of 4 times the absolute value of x minus 3. That's what our property says we can do. We're multiplying two things inside an absolute value. We're going to rewrite them as two separate absolute values with multiplication in between them. And that lets us keep simplifying because we know the absolute value of 4, that's just 4. So y equals, this negative comes down. So I put negative, absolute value of 4 is 4. So we get a negative 4 there, times x minus 3 plus 7. Now, don't make this mistake, ladies and gentlemen. I'm really worried someone's thinking, well, wait a minute. If the absolute value of 4 is positive 4, how did we get a negative 4? Remember, the negative didn't come from the absolute value. It came from that negative that's been sitting in front the entire time. All right, now all that work was just to get it into vertex form. Now that we see that invisible 1 in front of the x, and it's just x minus h, so there's no parentheses or anything like that inside the absolute value, now we're ready to go. We just find our vertex, find our a value, and then we just go to the graph. So the h value, it looks like it's a negative 3, so when we pull it out, it becomes positive, or we change the sign. K, we don't need to change the sign. K is exactly what it looks like. It's a positive 7. And then the a value is negative 4. Again, I'm going to put over 1 because we're sort of cheating and treating that like slope. Now it's time to graph. So I go to 1, 2, 3, and up 7 for our vertex. Going to the right, we do the normal slope. So that's down 1, 2, 3, 4, right 1. 1, 2, 3, 4, 1. With a little bit more space so my face will be out of the way. 1, 2, 3, 4, 1. 1, 2, 3, 4, 1. And that's as far as I can go. In the opposite direction, we want to create a V. Here it's going to be an upside down V because A was negative. So we go down 1, 2, 3, 4, and left 1 as many times as we can. Down 4, left 1, down 4, left 1, and down 4, left 1. And there's our absolute value function. So if I can draw this relatively straight, it's not going to be perfect, but I've got the most important points there, so it's all good. All right, so that's what we got. So obviously what made this one more difficult was the fact that we had a number in front of the x. We had to create our vertex form. It wasn't just already in vertex form. This is our last example for today, and I want you to try it on your own. This is example 3. Pause the video right here. Give this problem a shot. Come back when you think you have an answer. 3, 2, 1. Let's go. Right away, I see that this is not in vertex form. I see a 2 in front of that x, which means we've got to use a GCF to get it out of there. So let me rewrite it over here. So it's h of x equals absolute value of 2x plus 8 minus 1. And let's see, it's going to be h of x equals, remember, we've got to divide by whatever's in front of that x. So I'm going to divide by 2, divide that 2 out in front, and create our parentheses. Absolute value comes down. I put my GCF first, 2 times x plus 4. Now, if you ever need to double check that you did the GCF correctly, let me bring down that minus 1. If you want to double check you did the GCF correctly, just distribute. Okay, 2 times x, yep, that gives me the 2x. So far, so good. 2 times 4, yep, that gives me the 8. That means we didn't change this equation, we just rewrote it. We manipulated it so it looks a little bit different, a little bit better, because now we can use our absolute value property. Now I'm going to show all my work here. If you want to skip some of these steps, that's a good thing. I'm just showing my work. So this becomes, since it's 2 times the binomial x plus 4, that's the absolute value of 2, times the absolute value of x plus 4. I can separate that into 2 separate absolute values, since it's multiplication. And then we get h of x equals absolute value of 2, that's just positive 2, and the absolute value of x plus 4 stays the same, minus 1. Now it's in vertex form. We see that invisible 1 in front of the x, and we are ready to graph. Vertex, let's see, we've got an x plus 4, so that means the h is negative 4. We change the sign when we find h. K is exactly what it looks like. We don't change the sign for k, so k is a negative 1. Let's grab that vertex. So it's negative 4, negative 1. There we go. And our a value is 2. So that means I'm going to go up 2 and over 1 on the right. So up 2 over 1, up 2 over 1, up 2 over 1. Down too much, up 2 over 1. There we go. And going in the opposite direction from the vertex, we just reverse it. Not reverse it. We still go up, but we go to the left. Up 2, left 1, up 2, left 1. Keep going, keep going, keep going. And there we go. That is our absolute value function. Hopefully that's the answer you got on your own. Oh, that was terrible. Oh, undid all of it. Typical, really. What was I even saying? Yeah, hopefully you got this correct on your own. If not, just go back, check your work, compare it to mine, see where you went wrong, and hopefully it'll make sense after you rewatch the explanation. All right, time for your homework. Now, your homework's going to be a little bit different today. Your homework is going to be something we're calling a skill check 3-2. Now, this is obviously not in the textbook. I've got copies of the skill check, so you want to make sure you get one from me before you leave class. This skill check, what I want to say about this, it's sort of like a graded homework. So you're going to be handing this in tomorrow, and it's going to be graded for correctness. So you want to make sure you do, try your best, get the answer as accurate, as precise, as correct as you possibly can. Now, this is going to be in part of our, how do I want to say this, the formative assessment category, which is 20% of our grade. So this one skill check is going to be worth twice as much as all the other homeworks we've had put together. So it's really important that you get this done, get it handed in to me, and do your best on it. All right, as always, I hope this made sense. Reach out to me if you have any questions. Enjoy the rest of your day.